Hello, this is Miss Hall,
Hey, Miss Nelson.
and we have the notes for irrational numbers. So whenever you have a rational number is a number that can be expressed as a ratio of two integers written as a fraction in which the denominator is not zero. When you're comparing rational numbers, your common denominator is a common multiple of the denominators of two or more fractions, and your least common denominator, or we will refer to it a lot as LCD, is the least common multiple of the denominators. So take a minute and go ahead and fill in those notes and reread those so you have a good understanding of those definitions.
Okay, so when you are comparing two fractions, you have a couple of ways that you can do it. You can either turn them both into decimals and then compare the decimals and then get your answer, or you can get the common denominator like we just explained. So for these first three, I'm going to work them out with finding a common denominator. So if I'm looking, I have a 6 and a 9 that I am working with. So if I need to find the common denominator of those, you could always sit and list out your multiples of each one, and the first number that shows up in both is going to be your least common denominator. So for 6 and 9, your least common denominator is going to be 18, so I'm going to write them both over 18. And 16 times 3 was 18, so 5 times 3 is 15. 9 times 2 is 18, so 7 times 2 is 14. So now I'm comparing 15 eighteenths to 14 eighteenths, and the 15 eighteenths is bigger. Our second example, 2/5 compared to 7/50. Now, because I know my 50 will never make it into anything smaller than a 50, I know that I can get my 5 to turn into a 50. So 50 is going to be my common denominator. So I know that that fraction is going to remain the same. 5 times 10 is 50, so 2 times 10 is 20. So now I'm comparing 20 fiftieths to 7 fiftieths, and my 20 fiftieths are bigger. My last ones, I have a negative 9 sixteenths and a negative 7 tenths. So I know my common denominator is going to be an 80. Again, if you don't know that, you would just sit and list out all your multiples of 16 and 10 and find the first number that shows up in both. Now remember, these are both negative, so that's going to change what we do for our answer at the very end. So in order to get my numerator to change, I'm going to do 9 times 5, which gives me 45, so I have negative 45 over 80. And 7 times 8 is going to give me a negative 56. So now I'm comparing a negative 45 eightieths to a negative 56 eightieths. Now remember, the bigger the negative, the smaller the value actually is. And I made that note for you, so make sure you highlight that note, because I know sometimes we get a little bit confused when we have negatives. So because 45 is closer to 0, my sign is going to be that negative 9 sixteenths is greater than negative 7 tenths.
Okay, number 4. In second period class, 37.5% of students like to bowl. In fifth period class, 12 out of 29 students like to bowl. In which class does a greater fraction of students like to bowl? So we need to convert both those into something that we can compare. In this case, in order to do 37, we're going to put that into a decimal, which is 0.37, 375. So it's 375 thousandths. I really don't want to deal with that big of a fraction to have to try to simplify. So I'm actually going to convert the 12 out of 29 into a decimal so I can compare the two decimals. So remember, whenever you have a fraction, top in, bottom out, and we can get the decimal equivalent of any fraction. So we know that 29 does not go into 12, so we're going to put our decimal and add a 0. Now ask yourself how many times 29 goes into 120. I know 30 goes into 124 times, so I'm going to start there. So 4 times 9 is 36, carry my 3, 4 times 2 is 8, plus 3 is 11. Going to subtract. And I have remainder of 4. I'm going to bring down another 0. I know 29 goes into 40 once, and I'm going to stop there because that gives me enough to compare them. So this 12 over 29 ends up being 41 hundredths. If you want to go ahead and put a 0 behind here, so you're comparing thousandths and thousandths, if that helps you, then go ahead. And we clearly see that 410 is bigger than 375. So fifth period is the one that is the greater fraction out of those for second and fifth.
Okay, so whenever you are ordering rational numbers, meaning that you have a mix of numbers, fractions, decimals, percents, that you are working with, you need to get them all in the same form first. So it says you can order rational numbers using place value, express each number using the same form, either all fractions or all decimals, then order the numbers. So when I look at this, I know that I have a percent, I have a decimal, and I have two fractions. My personal preference is that I put them all into decimals. It's a little bit easier for me to work that way. That way I can go one digit at a time for each place value and compare them. So I know that 23% is 0.23. My 0.21 remains the same. I know that 1/4, if you think of it, that's a benchmark fraction, so you should remember that from last year. That's 0.25. And 1/5, again, that's a benchmark fraction at 0.20. So it tells me from least to greatest. So I'm going to go and compare these and find the smallest and work my way up. All of them have a 0, so I go to the next place value. All of them have a 2, so I go to the next place value. I'm now comparing a 3, a 1, a 5, and a 0. So I know the 0 goes first, then the 1, then the 3, and then the 5. Now, it's important to remember that you must write them in the original form that they were given to you in. So since my smallest was 0.20, that was my 1/5. My second was already a decimal, so 0.21. My third was my percent. And last was my 1/4. So again, make sure you always put them back in the original form whenever you're ordering them.
Okay, so Maddie's a guard on the basketball team. She made 70% of free throws her first game. She made .62 3/4 and 66% of her free throws in the next 3 games. List Maddie's free throws statistics from least to greatest. I always like to underline what I'm looking for because I will do all the math and then forget, and I might do it the opposite way. So first I'm going to write down what I'm looking for. So I have set what I'm comparing, 70%, and I have .62 3/4 and 66%. Okay, 70%, remember up here at the top, above in the notes, to change a percent to a decimal, you move the decimal 2 places to the left. I'm going to put them in all decimals so I can compare them. So this is .70. This is already a decimal, so I'm just going to bring it down. 3/4 is a benchmark fraction that you should remember from last year, and that's .75. Think quarters. For 3/4 is 75 cents, and then I'm going to move my decimal twice on this percent, so that's .66. So now I'm going to list them least to greatest. So my least out of these numbers is 62. So this is 1, and then my next is 66. Then I have 70 and 75. So like Ms. Nelson was saying, list them from in the original format. So we have .62, 66%, 70%, and 3/4. Okay, y'all have a good day. See you tomorrow.
Bye.